Okay, guys, this is now chapter 6, demo. And oh, chapter 6, number 9, which is involving confidence intervals. Except this, you'll see in a second, is a little bit of a trick question. In fact, in real life, you'll hardly ever see this. There are two kinds of problems that we're seeing in these chapters, those involving Z and those involving T. Z is used in a rare situation when you know the population standard deviation symbolized by sigma. Of course, you know that the interval is a little more precise and the Z, in fact, is a little bit smaller than the corresponding T. On the other hand, the most common example is when you're given the sample standard deviation based on the sample that you collected, and then you go to the T. But this is one of those rare cases where you go to the Z. So you first click on this sample, which is much more than a sample. It's a very large set of data. So we'll call it the whole population. Open in StatCrunch. I think it's easy to do in StatCrunch, at least for me. Let's go to Stat, Summary Stat, Columns. Both columns. I'm not really. Oh, I think you have to add them together. Just remember that. Okay. Let's go cancel. Let's create a column called the sum. And I believe we can do that by going to Data, Compute, an expression. And the expression is going to be checking plus savings. Checking plus savings. I'm not sure if we need to have. I guess we have to say compute maybe. Build. No, try it again. Let's do capitals. Checking plus savings. Okay, that worked. So we have a new column called checking plus savings. We don't need this column anymore. And now we can summarize this column. If you recall, it has lots of data, hundreds of numbers, the whole population. To stat, summary stat, column. This is the column. We really want the standard deviation only, but we might as well get everything. Say compute, and the standard deviation turns out to be an unusually large 4826.99. Let me copy that. Okay, now, so we want an 80% confidence interval based on the sample. Now here's the sample now. Open in StatCrunch. Again, we can create a variable called data, compute, expression, and the expression is checking for savings. I'm using the plus in this case, we would simply add them together. Compute, we have our column. And now we can calculate the 80% confidence interval the following way. You go to stat, ZStat. Again, it's one of the rare times you're going to be going to ZStat. One sample with data, because we have the raw data. This is the column we're focusing on. We put in the standard deviation, which we said just now is got what it was. Control V, 4826.99. We want confidence interval. We want 80%. And that's it, compute. And the answer will be minus 264.93, the lower part of the estimate. Control V. And the upper one, if I can still find it somewhere, is 2501.53. Copy. Check answer. After all that, let's see what we did wrong. Numbers again. Did you say wrong? 20. Technical difficulty 2501. This answer I said was 2501. Oh, I must have wrong. Okay, plain and little confidence. So we know it to be 2986. 80% of the mean total assets. No idea what I did wrong. Let's try it again. We have checking plus savings, that's right. We want to do a stat. Did I go to Z? I hope I did. With data. On this variable, on this standard deviation, which whatever it was a few minutes ago, where group by confidence interval 80%. No, I have no idea what we did wrong. Let's check it again. Put this aside. Check answer. And we got it wrong. Check answer. Look at that. We're off by 1 or 2. Why is that? Oh, you know why? I think I know why. Okay, this is a subtlety. Can't believe it. This is what book expects you to do. Okay. The subtlety has to do with the fact, let's go back to the population data. Sorry for this divergence, but maybe you learned something from this. Open the StatCrunch, and I said calculate, first of all, the sum. We'll call it, well, let's call it data, compute, expression, checking plus savings. Checking plus saving. Compute. So we have a new column. Okay. 0 plus 793, 739, 739, etc. Okay. Now, what is the standard deviation of this column of data? So we go to stat, summary stat, columns. We want this column. And here's where you have to be a little more precise. We want the unadjusted. I guess it's a subtlety. The standard deviation of a sample has an n minus 1 on the bottom. N is the sample size minus 1 for technical reasons, which again I explain in the videos that I think you should watch in conjunction with these other demonstrations. But the population has an n. Now the truth is I can't believe this is going to make a difference, but because it's such a large sample size, but let's compute it. And it comes out to 4821.31. 4821. Copy. Now let's try to get the 482031. Let's try it again. I'm going to put this aside. Now we're going to go to the second set of data. Open that in StatCrunch. Again, we have to compute the sum because we're talking about data, compute, expression, checking plus savings. And we have our new column. Simply enter. Now we go to stat, ZStat, one sample with data, where we want this column. We know the standard deviation is, what did you say, 4821.31. We want confidence interval. We want 80%. We didn't mess that up. And now we say compute. And we're seeing minus 263.31 to 2499. Let's see, what do we say? What's the right answer? 263, yeah, now it's right. 263.31 to 2499.91. Verify that. Yep, there it is. 24.91. Okay, so we must have made some mistake. Maybe I didn't use the unadjusted, which is a very, very subtle point that you have to be aware of. Assuming now we know it now to be 85%. Well, that's easy. You just change this to an 85. You go to that summary, I'm sorry, ZStat, one sample with data. You want this variable. We know the standard deviation is staying the same, but now we want confidence interval of 85, which is a very strange size confidence interval. Where to go? Where are we? Compute. And this time we get minus 433.62. And the upper end is 2670.22. Control C. Where are we? Check answer. And this time I got it right. Now they want, oh boy, now they want 95%. Do we have to do it again? All right. If you want, just change this to, still need, oh, we have to go back. Oh, standard deviation 4821.31. We have that. We don't have to recalculate that. Let's get out of here. Let's go to stat, ZStat, one sample with data, checking, optional, 95% this time, I believe. It's going to be bigger, of course, wider, minus 994.69. Copy. And again, the interpretation, again, is discussed in detail in those videos, that if you want to know the basic theory behind it. The upper limit is 3231.29. C. Control V. Check answer. And we did it. Oh, no, I want more to this question. Okay, explain the differences. Is larger, is wider. 95 is wider than the 80%. The 85 is wider than the 80%. Interval becomes wider. And that makes sense because again, a higher percentage means we're more sure. And the only way to become more sure is to make the interval wider and less precise. Oh boy, more yet. How did the confidence interval differ between populations? Okay. Well, the answer I just told you was that you're going to go to the t-table. The t-table is slightly wider. Now they want you to go back. Question is, which one are we going to be using? The first one or the second one? Is it the population credit risk or the sample credit risk? I'm not sure what they mean. Assuming the population is not known, the mean total assets held is, well, I'm going to assume we're talking about the second data. That's even easier. You just go to open in, oh, got to go back to our combined, rid of this. Now we're going to do the following. Stat, t-stats now, because we don't know the standard deviation. One sample with data. This is a variable. You want it to be 95%, I believe. Compute, and it's 720 to 15, 2015, copy. Again, I wouldn't bet my life on this because I'm not sure which one of these two samples they're talking about. The other one, and it's got to be the end of the problem, is 1516.44. I hit this over. It's 1:30 in the morning for me. Oh no. Okay. Both your answers over. Don't use ascending order. Oh, yeah, my mistake again. I apologize, but again, mistakes are valuable. They want 80% confidence interval. We can do this really quickly. So we're going to go here. Well, we have the data already. It's here. We are going to start again. We have the sum, so we're just going to go to stat, t-stat, one sample with data, this variable, confidence of 80. Now we compute. Again, we still may not be right because I'm not sure which of the two populations are talking about. 860 times 73, let's try that. And the bigger number, the higher end of the interval is 1370. And again, we're saying we're 80% sure the real answer is somewhere between here and here. So when you take a sample, you're never sure if the sample really is reflecting the full population. Check answer. Whoa, now I got it right. Oh, now they wanted 85% again. They're really ridiculous. And I guess I'm the one who gives out the assignment, so yeah, I guess I have to blame myself. We go back here, erase this, that, t-stats, one sample with data, this variable, and this level of confidence. Compute, and 832.92, copy. Notice it's a little bit bigger than the other one because we're starting, a little bit smaller because we're making a wider interval, starting at the earliest spot. And the other end of this interval is 1403.67. C. Answer. I bet they're going to make us do a 95 as well. Check answer. I got it right. Now they're going to probably say 95, which was my first answer, which I forgot what I said. But it goes so quickly. Let's do it again. Race, stat, t-stat, one sample with data, this variable, this 95. So that's the most common number. Compute. 720.15. Copy. 720.15. And a high number is 1516.44. And check answer. Good. And now they're going to ask us. The 80 is the 80. Again, when you know okay, here's the deal. In theory, if you know the population standard deviation, it's more accurate, so it's going to be a little more narrow. Without even checking it, if you could check the actual numbers, this versus that. let's see what's happening here. The 80. Oh, you see, oh my God. You see, this is a very strange example. So let me explain this, why this is coming to an anomaly. Generally speaking, if the actual standard deviation was the same, the z would be more narrow than t. But in this case, the original standard deviation of that big population, these numbers here, was very large. It was like 4,000. And the standard deviation here of these numbers is much smaller. So that even though theoretically it should be more narrow, in actuality it's wider, I believe. That's very strange from an educational point of view. Check answer. And we did it right, but it was pointless for that. And we're done with the question. Okay, I'm going to stop this now, and hopefully that was useful to you.